From the given information that Math Dude provides, it's on the initial amount given is 1 penny. So on day 0 there was 1. On day 1 it doubles, and so there'll be 2 pennies. On day 2, 4 pennies. And then he goes on to say that at the end of the week, on the 7th day, is 128 pennies, or he says $1.28, and then students realize that that's 128 pennies in the table, and so they have to fill in the rest of the amount where the output's doubling. And then I say, my question is this linear? Well, on the graph, they can see that the curve, they may not understand that the x-axis is the asymptote, and the horizontal asymptote that it doesn't cross, but they do see that it is a curve on the right-hand side of the graph in the first quadrant, and that it is increasing rapidly. And also, if we look at the output of the table and look for that pattern to see if it's linear, they subtract the previous amount, 2 minus 1, that's going to be 1. And if they subtract 4 minus 2, that would be 2, and subtract 8 minus 4, that's going to be 4, and 16 minus 8 would be 8. And so they can see that it is not a constant rate of change, but what is happening with the output. And so we look at the output values by themselves. So if we had, so it is not linear, and so we try something else and say, well, what is happening with the output? And so if I look at the output values of 1, 2, 4, 8, 16, they can see that it's doubling, and a lot of times the students wanted to write, the ones that did try to write the equation, wrote 2 times x. Well, for one thing, it's not 2 times x, because x to the first power would be what on the graph? It would be linear. And then if you look at the table and see if that equation matches up with the graph, if you substitute 0 in for x, 2 times 0, you get 0, not 1, like you should get for the output. If you input 1 in for x, you get 2. So that matches up, but day 0 didn't match up. Substitute for day 2, you get 4, and 2 times 3, you get 6, which you should have got 8 for the output, according to this table of the data that was given. And so, where did these values come from? And I keep questioning students, and it does take a little bit of time for students to realize, well, it's 2 to a power. Well, how do you write 2 to a power where it's going to match up with the table? So they know 2 is in the equation because of the doubling, and they know double means to multiply times 2, but now that they realize that the equation 2 times x doesn't work, we put 2 here and say, well, where are you going to put the variable in the equation? Well, it has to be in the exponent, and it takes a little bit of questioning to get there, but if you we try that out, you get 2 times to the 0 power. Anything 0 power is going to be 1. If you put in, so that's your y is equal to 1. If you had 2 to the first power, you get 2. 2 to the second power, you do get 4. 2 to the third power, you get 8. And so we talk about, well, this is an exponential equation. And is this one increasing or decreasing? Well, this one's increasing very rapidly, and so that's going to be an exponential growth function. And then the next day we look at, in the next lesson, we'll look at exponential decay.